Hey everyone, today I'm going to talk about how we can use the bitwise operator to solve the DSA problem. Let's take one problem. Given an array in which every element repeats twice except one, you need to find the element which occur once. There are different approaches to solve this question. One approach is to store the count of every element and at the end return the element whose count is 1. This approach requires the space complexity of O of n, where n is the distinct number of elements present in the array. So, can we solve this question in without using any extra space? The answer is yes. We can solve this question using the bitwise operator XOR. As you know, the bitwise operator XOR returns 0 if two bits are same. It means if two numbers are same, their bit is also same. So at that point, if we take the XOR of two number, it becomes 0. So for a array which contain the duplicate element, if we take XOR of the array, then the duplicate numbers XOR becomes 0, and at the last the XOR of the array become equal to the number which occur once. So we can use this property to solve this question. To find the element which occur once in the array, we defined the function find one repeat num, which take a vector of integer as an argument and return the the element which occur once. So at the beginning we define a integer answer equal to 0, which basically answer will keep track of the XOR of the array. So if we iterate over the array and take the XOR of every element, and at the end we return the answer. As we know, the XOR will become 0 in case of the repeating element. So at the end we know that our answer should contain the element which occur once in the array. Let's take one example. Our size of array is 9 and our array contain 4, 6, 7, 5, 6, 7, 5, 3, 4. As you can observe, only 3 is the element which appear once in the array. So we going to take XOR of the array to find the element which occur once. So at the beginning XOR is 0. At the first iteration the XOR of 0 and 4 is 4, and at the second iteration XOR of 6 and 4 is 2, and at the third iteration XOR of 2 and 7 is 5, and at the fourth iteration 5 and 5 XOR is 0, and next in the fifth iteration the XOR of 0 and 6 is 6, and at the sixth iteration the XOR of 6 and 7 is 1, and at the seventh iteration the XOR of 1 and 5 is 4, and at the eighth iteration the XOR of 3 and 4 is 7, and at the ninth iteration the XOR of 7 and 4 is 3, and at the end the XOR become equal to the element which appear once in the array. Let's try another question. Given an array in which every element repeated twice except two elements, you need to find the two elements which occur once. One approach to solve this question is to find the count of every element and at the end return the element whose count is 1. We can use the bitwise operator XOR to solve this question. So, as we know, the XOR of two equal element is 0. So, if we take the XOR of the array in which every element repeated twice except the two element, then at the end our XOR become equal to A XOR B, and where A and B are the element which repeat appear only once in the array. And if the ith bit of A XOR B is 1, it means that this ith bit should be on in either A or B. It cannot be on in both of the element. So now we can use this ith bit to form two set. One set contain A and another set contain B. This set 1 will contain all the element whose ith bit is on, and set 2 contain the uh, the uh, uh, element whose ith bit is off. So now we have two set, and as we know, the every element repeated twice. So the XOR of set 1 is A and XOR of set B 2 is B. So we will use this approach to solve this question. So for solving this question, we define a function find two non-repeating which take vector of integer as an argument and return the pair of integer. And at the beginning, first we find the XOR of all element, and in the next step we find out the on bit, uh, and at the in the next step we will iterate over the element and check if the ith bit is on. We will take XOR of this element in A, and otherwise we will take XOR of this element in B. And at the end, as we know that set 1 XOR is A and set B XOR is B. So we at the end we will return this element A and B. Let's take one example. As you can see that our array size is 6, and in our array every element is repeated twice except two elements. First we will take the XOR of the array, so we will iterate over the array and find the XOR of the array. So at the 0th index the element is 2, so XOR of 0 and 2 is 2, and then 2 and 3 XOR is 1, and again 1 and 4 XOR is 5, 5 and 3 XOR is 6, and 6 and 5 XOR is 3, 3 and 2 XOR is 1. And then we will find the on bit in the XOR. So 0th bit is on. So we will use this 0th bit to differentiate between two set. If this 0th bit is on, so we will take the, the element XOR in A, otherwise take the element XOR in B. So as you can see, 0th index, the value is 2 and its 0th bit is off, so we will take its XOR in B, and at the 1 index the 0th bit is on, so we will take the XOR in A, and at the second index the 0th bit is off, so we'll take XOR in B, and again at the third index the 0th bit is on, so we will take it XOR in A, and at the fourth index the 0th bit is on, so we will take XOR in A, and at the end, at the fifth index, the 0th bit is off, so we will take its XOR in B. So at the end, A is 5, B is 4. So this 5 and 4 denotes the element which didn't appear twice in the array. So at the end our answer is 5 and 4. Don't forget to practice this concept. Code, compete and